Okay, so we're continuing our review of different methods for factoring, and now we're moving on to grouping when there are three terms. So with that little introduction, let's get started on our problem. And this is our list of methods, again, making sure that you're good with all of these. If you weren't good with greatest common factor, you should have already watched that video. Same thing with the four-term grouping, because now with the three-term method, we'll be using these other things in that process. I want to remind you there are alternate methods to this. So as I factor this using grouping, if there's another method that you prefer, you are welcome to use whatever method you like. It's just this is the only method that I'm going to teach. All right, so three-term grouping. Remember, anytime we're trying to find roots, intercepts, zeros, whatever you want to call them, we always begin by plugging in a 0 for y, which h of x is the same as a y. And now at this point, this is where our factoring review is going to begin right here. So from this point on, for the next couple steps, this is our review of factoring. So when we did grouping with three terms, the first thing I wanted to do was recognize what number is in front of x squared. So in this case, there's a sneaky ninja 1. And what number is at the end, keeping the sign in mind. In this case, it's a positive 25. Actually, I'm lying. We said at the beginning, we're going to ignore signs. So I'm just going to say 1 times 25. We're going to multiply these two things together, ignoring the signs. 1 times 25 is equal to 25. And then we find all the factor pairs of 25. So 1 times 25, 5 times 5. And in this case, that's it. There's not a lot of factor pairs. That's all we have. Okay, so that was our first step. Our next step, again, ignoring the signs, we want to find the pairs that do this thing to equal that number. Okay, so the pairs that add up to equal 10. Again, we're still ignoring signs right now. The things that add up to equal 10. If this was a negative 25, then I'd want the things that subtract to equal 10. But since it's a plus 25, we want the things that add to equal 10. So ignoring signs, these two are the ones that add up to equal 10. 5 plus 5 equals 10. Now, at this point, this is the only time that we look at signs. I want to give these are the numbers I'm going to use. I choose my numbers ignoring the signs. But then to figure out how I'm going to actually plug them into the equation, I need to decide, do I want them to be positive or negative? And now this is where I look at the fact that I want it to be a negative 10. So I know that I'm going to add these. I know that. And I need them to add to be a negative 10. So that tells me that they must both be negative to start with, right? Because negative 5 plus negative 5 equals negative 10. The good thing with this, once you get to the point that we know we're adding these, there's only so many options. So you could check them. You could make them both positive. You can make one positive and one negative. You can make the other one positive and the other one negative. And then you could also make them both negative. There's only those 4 options. So once you know that it's going to be these numbers, and once you know that you're adding, you can just check to see which one works. And in this case, to get negative 10, this is the one that works. So I'm going to take that middle term and I'm going to break it up into a negative 5x plus a negative 5x. Or you could just make it negative 5x minus 5x, however you want to write that. So that's my breaking of the middle term. And once I do that, remember the other things are all still there. I haven't changed any other part of the equation. Now I have 4 terms. And from this point on, it's the same as factoring with 4 terms. There's no different. I take a look at the beginning 2 terms, and I treat that like one problem. I take a look at the last 2 terms, and I treat that like a separate problem. So is there a number that divides 1 and 5 both? Just 1. Do they have variables in common? Yes. What's the smallest exponent? It's a 1. Is my leading term positive? Yes, it is. So I'm going to just take out a positive x. There's my first greatest common factor. Okay, what's going to be left behind? Well, x times x gives me an x squared, so there must have been an x here. And x times negative 5 gives me a negative 5x, so there must have been a negative 5 there. So there's that part. Now, in the next part, I know the parentheses have to match. So x minus 5 has to be my parentheses. What did I distribute? Well, for this, I can just divide. A positive 25 divided by a negative 5 That equals -5. So that must have been what I distributed. And then I just do a quick double check. -5 times x, yep, that works. -5 times -5, yep, that works. Okay, so I still have the equal 0 out in front. That hasn't gone away. Now I know that the part that is in parentheses was distributed to something else. So the part that's in parentheses, that got distributed to something else. Well, the thing that was in the front must have been an x. And the thing that it was in the back must have been a -5. And so there we go. I now have a complete factorization. So there's my review of factoring. That's the point of this video right there. Okay. Now, I will say there was a time where we talked about shortcuts, because notice I'm getting the exact same thing twice here. And there was a shortcut for this, but again, to save time for the purposes of this, if you want to review that shortcut, go back to the stuff from last chapter or last semester to review that. All right, now to finish actually finding the roots, what we'll have to do is set both of these equal to 0. Well, the nice thing is because they're the same, they're both going to give me the same answer. So I really only have to do it once. I don't have to do it twice. Add 5 to both sides, x equals 5. That's going to give me the same answer. That tells me that I only have one x-intercept. It's the point 5, 0. All right, so there is our review of grouping with 3 terms. Thanks for watching.